Good day. Something you will use a lot in the wacky world of equilibrium math is the equilibrium constant. So if we have an equation where A, B, C, and D are sorted chemicals, A and B are reactants, C and D are products, and the lowercase letters, the little a and b and little c and little d are coefficients, we can take that and we can produce an equilibrium constant expression. And when we do that, it's always products over reactants. So we have the big C in square brackets. So you should remember from last year, square brackets means concentration. Concentration of C to the C power. Concentration of D to the little d, whatever that number is. Concentration of A to its coefficient. Concentration of B to its coefficient. So maybe that's making it look tricky, but it really isn't. Sometimes in books you'll see it as Kc if it's all concentrations, or Kp if it's all based on pressures. In general, in this course, we just call it Kq, Eq for equilibrium. Now, when we're writing out these expressions, we're going to worry about things that are gaseous or aqueous. Things that are solid or liquid have fixed densities, and since that means they have fixed concentrations, and this is a constant, we don't include them because they wouldn't be changing as well, depending on temperature and things. So some examples will make this look very straightforward. So if I have this equation, chemical equation, I have CO, coefficient of 1, Cl2, coefficient of 1, in square brackets. I don't bother writing the ones. COCl2 at a coefficient of 1. So that is the proper equilibrium expression, and you've got to get good at writing that. In this case, I only have one product, the NO2, and a coefficient of 2, so it's squared. NO, square brackets, to the second power, and O2 to the first power. Here I have CH4 gas and no coefficient. Carbon's a solid, so I don't include it in the expression. And H2 has a coefficient of 2, so it is squared. And these are all ones, so these things are the products on top. These are the reactants on the bottom. Anytime you have a Q value of over 1,000, that means it's strongly shifted to the right. If you have a KQ value of under 1/1000th, that means it's strongly shifted to the left, to the reactants. And if it's in between those two numbers, 1/1000th and 1,000, then it means it's a fairly balanced chemical equilibrium. You're going to have a fair amount of products and reactants. And we'll just do a few more examples. And so here we have O3 and 2 and 3 O2s over here. And so no surprise, O2 cubed, O to third, ozone, O3 squared. These things are all gases, so there's our NOCl squared over NO and the Cl to the power of 1. And here we have a bunch of ions, they're all aqueous, and so products divided by reactants, and we have to remember there's a 2 there. So by now, I think you probably have got the message. Writing these things out is straightforward, and you'll be doing it a lot. And many times a question will give you a value of KQ, or it may give you concentrations that you plug into these expressions to figure out the value of the KQ. So hopefully that makes sense.